Welcome to sitza.com.
Enthalpy of solution. Enthalpy of solution is defined as the heat released or absorbed when 1 mole of a compound is dissolved in excess of solvent. If you have a 1 mole of a solute and you put it in excess of a solvent, heat is either released or absorbed. For certain substances, for certain salts, either the heat is released or it is absorbed. So we say the heat that is released or absorbed when you put 1 mole of a substance in an excess of solvent is called as the enthalpy of solution or heat of solution. For example, if you take 1 mole of the sodium chloride and you put it in an excess of solvent, so the heat change that occurs here will be called as a heat of solution. NaCl, when you dissolve in excess of solvent, in an excess of the water here, so what do you get? You get the sodium ions aqueous and chloride ions aqueous. And we also find that the heat change here is positive. About 4 kilojoules of heat is absorbed when you put the NaCl, 1 mole of NaCl in an excess of solvent. So you can say that heat of solution for NaCl is 4 kilojoules. Similarly, if you put magnesium sulfate, another salt, in an excess of solvent and you get the magnesium and the sulfate ions aqueous, the heat of solution for this solute is negative 91.211 kilojoules per mole. That means this is the amount of heat that has been released because it is here the negative. So negative indicates that the heat is released, right? For the NaCl, it is positive. That means the heat of solution or enthalpy of solution can either be positive or it can be negative. Now let's see what happens actually when you put a solute like NaCl in the water. We know an NaCl in the solid state, in a crystalline solid state, the ions are very tightly bound. There's a strong force of attraction between the cation and the anion, right, in the solid crystalline state. And the ions cannot move. They are tightly bound together, and the force of attraction in the crystalline solid is very strong. When you put the same solid in the water, what happens? These ions actually in the water, water we know is a polar, right? Water is polar. It has a hydrogen which is a delta positive and oxygen which is delta negative here, right? So when you put any solid in the water, what happens there? The ions which are actually tightly held together in the crystalline solid, they get dissociated, and in the aqueous solution, in the solution form, the water molecule starts interacting with the cations and the anions. So water, as we know, is a polar and it's gonna interact with the cation and the anion. It is a negative end of the water, which is oxygen, that will start interacting with the cation. So there is a force of attraction that will develop between the cation and the anion. And similarly, you will have a force of attraction between the anion and the solvent molecules. Now it is the hydrogen which is actually having some delta positive charge. The positive part of the water that will start interacting with the anion, right? So the force of attraction will develop now between the solute and the solvent molecules, right? A cation will be surrounded by the water, but it will start interacting from the negative end, from the oxygen end. Anion will be surrounded by the water molecules, but the force of attraction will start from the hydrogen end, right? From the positive end of the water. So due to this interaction, due to this attraction between the cation and the anion with the solvent molecules, with the water molecules, some energy will be released, because we know wherever there is attraction, there is energy loss, right? So due to this attraction between the ions and the solvent molecules, some energy will be lost, which is called as a hydration energy, right? So hydration energy. We use another term also which is called as a solvation energy. Solvation energy is a general term. We use it for any solvent, right? When any solvent interacts with the solute. Hydration we use specifically when we take the water as a solvent, right? So general term is a solvation energy, and specific with the water will be called as a hydration energy. So what is the total energy change? What is the net energy change when you put NaCl in the water? Let's try to examine this whole process. What happens? What kind of energies are involved when you put an NaCl in the this water? Basically, there are two types of energies, right? Number one is lattice energy, right? Another one is a hydration energy, and it is this, the sum of the two which gives us the solution, enthalpy of a solution, the heat of solution, right? So the heat of solution or the enthalpy of solution is basically the sum of the lattice energy and the hydration energy. Hydration energy is this much, right? When solvent molecules start interacting with the ions, right, with the cation and the anions. So what is the total energy change, right? That depends on the summation of the lattice energy and the hydration energy, and it can be either positive or it can be negative, right? As I said, this hydration energy is always exothermic. It will always be negative, right? Because whenever there is attraction, there is some energy loss, right? Due to the attraction here between the solvent molecules and the ions, some energy is lost, some heat is lost, right? And that's called as hydration energy. When you put 1 mole of NaCl in the water, so the solvent molecule will start interacting with it. The heat released here will be called as a hydration energy. But what is enthalpy of solution and how is it related with this? As I said, there are two types of energy, right? Number one is a lattice energy. Lattice energy is basically the energy that you need to break the bonds, right? Break the, you need to break the ions actually. You need to separate the ions from the crystalline solid. In a crystalline solid, the ions are very, tightly held together. So the force of attraction is very strong. And when you put in the water, you need to dissociate these ions. To dissociate these ions, you need some energy, which is called as a lattice energy, right? Lattice energy. Lattice energy, I have a separate video on it. What are the factors on which it depends? Here I'm going to explain you briefly about the lattice energy. Lattice energy actually, it tells us about the interaction, how strongly these ions are held together in a solid, in a crystalline solid, right? So the force of attraction that is there between the cation and the anion in the crystalline solid is actually the lattice energy, all right? So lattice energy actually depends on two things, right? It depends on the charge of these ions and the size, right? You can say that lattice energy is directly proportional to the charge of the cation and the charge of anion, and it is inversely proportional to the size of these ions. So more charge means more lattice energy, means ions will be held strongly. So when you put a solute, when you put an NaCl in the water, you have to dissociate these ions, you have to separate the ions, you need some energy, and how much of energy you need? Equal to the lattice energy. So that means you need some energy to dissociate these ions from the crystalline solid, and the energy that you need is the lattice energy. So if there's a strong force of attraction between the ions, lattice energy is more, and this will be always be positive, right? You require energy here, right, to actually dissociate these ions. And after you dissociate, what happens? The solvent molecules start interacting, right? The solvent molecules start interacting, and the energy that is released here is called as the hydration energy. Now the total energy change that occurs, in this whole process, you can say if you have an NaCl, let's suppose you have an NaCl solid state, you have to first dissociate into ions, okay? You have to dissociate into ions. So after you dissociate, what you get? You will get, the sodium ions and the chloride ions, right? So for that you need energy, right? You need some energy, which is called as a lattice energy. You can break these, you can dissociate these ions from a solid into the gaseous state by giving energy equal to the lattice energy. As I said, this lattice energy depends on the charge, right? If there's more charge, so you need more energy. And after you dissociate these ions, what happens? What is the next thing? The next thing that happens in the solution is that these ions are surrounded by the water molecules, right? So this is the second energy, right? Now the energy that is released here when you actually, when these ions interact with the solvent is called as a hydration energy. Okay, this is the hydration energy, and this is a negative, this is an exothermic. Lattice energy, this step is positive, right? This is endothermic. So you need energy here to dissociate the ions. In the second step, once the ions have been formed, these ions will be solvated, hydrated. So energy will be released. Okay, and what you get? You get the sodium ion aqueous, and you get the chloride ion aqueous. So these are the two steps, right? And I can say this is the direct process, right? This is the net reaction. This is the net process actually, right? The net process is that, when you take an NaCl solid state and you want to convert it into the aqueous sodium ions and the chloride ions by dissolving in the water, the net energy change that occurs here, basically that is what you call as a hydration energy, or you call it as a solution or enthalpy of solution. Okay, heat of solution or the enthalpy of solution. And this enthalpy of solution now is the sum of the lattice energy and the hydration energy. As I said, it can either be positive or negative, depends which is higher. As I said, this enthalpy of solution is a summation of the lattice energy and the hydration energy. If lattice energy is more than hydration energy, correct? If this one is more than hydration energy, therefore the delta H will be positive. Delta H solution will be positive. Enthalpy of solution will be positive if this part is more, correct? Because this is an endothermic step, right? This is an endothermic step. You require here heat to break these, to dissociate these ions, okay? And if this lattice energy is more than hydration energy, the enthalpy of solution will be positive. And if the hydration energy is more, the heat released here in the second step is more than the lattice energy. Suppose you need very small energy to dissociate these ions, and a lot of heat is released when these ions get solvated, when they get hydrated. So if hydration energy is more here, if this is more than the lattice energy for that particular solution, substance, for that particular salt, you can say the enthalpy of solution will be negative, right? Here I'm gonna show you certain examples with the positive and the negative enthalpy of solution. You can see the ammonium chloride, right? A lot of heat is here. What it is absorbed. You can see about 14.78 kilojoules of heat is absorbed when you take 1 mole of ammonium chloride in excess of solvent. So you can see all these salts, they have the positive these enthalpy of solution. So that means for these substances here, I can say that enthalpy of this lattice energy is more than the hydration energy. Okay, that's why this is positive. Enthalpy of solution is positive here. And for these salts, lithium chloride, lithium bromide, for all these salts, the enthalpy of solution is negative here. So I can say for these salts, the enthalpy of hydration is more than enthalpy of the lattice energy. Okay, so that's why this enthalpy of solution is negative here. So enthalpy of solution, it can be positive or negative, and it is defined as the energy change which occurs when you take 1 mole of a solute in excess of solvent. Hope you got it. Thanks for watching the video. Bye for now.